So that's it for the discrete distributions we'll talk about. Now I've got a few special continuous distributions to mention which come up a fair bit in life. The first of them is, it's the easiest, it's a pretty simple one. It's a uniform distribution. This is what you get if your density function is constant over some interval. The parameters of the uniform distribution are alpha and beta, the endpoints of the interval. So if it's equal to some constant, what's the value that it's going to take? All right, to be a density function, the area under the curve must be 1, so the overall possible values. And what we got here is a rectangle. Our distance there is beta minus alpha. So the area under the curve, it's got to equal 1. Base times height has to equal 1. So this height is going to have to be 1 on beta minus alpha, so that when we multiply that by that, we end up with an area of 1. So the density of a uniform distribution is 1 over beta minus alpha between alpha and beta, otherwise it's 0. It's easy to derive the CDF function. It's going to be a straight line function increasing from 0 to 1 with constant gradient between alpha and beta. If you want to know the mean and variance of the distribution, well, it's just integrating x and integrating x squared. It's no big deal to derive these results. The mean ends up being alpha plus beta on 2. Remember, the mean is the center of gravity of a distribution. This is the center of gravity of its probability distribution, I guess you could say. If you've got a chunk of wood and you want to balance it on one finger, you've got to pick the middle, don't you? This distribution is symmetric about its center point, alpha plus beta on 2. So that's its mean. And the variance is a function of how wide the interval is. Beta minus alpha squared divided by 12. So some useful properties of the uniform distribution. Well, if you want to derive probabilities for it, we're just talking rectangles, so it's pretty easy to do. You don't need to do the integral. You could just say the width multiplied by 1 on beta minus alpha of the interval you're interested in. That gives you your answer. And the other thing to know about the uniform distribution is that any linear transformation of it will still be uniform. All we're doing with a linear transformation is changing the scale of the x-axis. We're not changing the shape of the distribution.